This is 12.2. We're doing logarithmic functions, and our objectives for today is to learn how to change from logarithmic to exponential form, and change from exponential form to logarithmic form, so they go back and forth. And then we're going to evaluate logarithms, and that's all we're going to do today. So really, this is going to be called part 1. You got the notes for the whole section 12.2, but we're going to split it up into 2 parts. So let's look at what these forms are. You have, it says location of base and exponent in exponential and logarithmic forms. So you're going to be able to move back and forth between these 2 forms. So a logarithmic form, you have y equals log base b of x. And when you're in that form, b is the base, the little subscript b, and the exponent will be what it equals to. And so if we change this logarithmic form to an exponential form, we'd say, all right, b is our base, and then it's equal to y, so that's my exponent, and then that equals x, which is what's left here that we didn't label in my logarithmic form. So you can go back and forth between these 2 just by knowing what position goes where. And that's what we're going to do in the first example. So let's look at it. It says, write the equation in its equivalent exponential form. So we're in logarithmic form, we got to write it in exponential form. So we got to write it in b to the y equals x form. And remember, b is the base, and in logarithmic form, it's what's after the log, the subscript, that's our base. So it's log base 5. And so when we write this in exponential form, we're going to say 5. And what that equals to, which in this case is 2, that's the power on the 5. So you got 5 squared equals x. And that changes it to exponential form. Let's look at b. Now our base is b. The exponent is 3, because this is the exponent, and that equals 64. And c, the base is 3, the exponent is going to be y, and it equals 7. And that's all there is from changing from log to exponential. So go ahead, pause your video here, try your checkpoints. When you come back, I'll give you the answers. So checkpoint 1, the answer is 7 to the 3rd equals x. B is b squared equals 25. And c is 4 to the y equals 26. Let's look at the example 2 on how to change the other way. So we've got in example 2, we're changing from exponential to logarithmic. So we've got 12 squared equals x. We want to make it logarithmic. And so it's log of whatever base. So the subscript is whatever base. In this case, my base is 12. So it's log base 12. And what it's equal to in exponential form is what we're taking the log of. So in this case, it's the x. So it's log base 12 of x, and that equals the exponent, which is 2. Let's do b. We got log base b of 8 equals the exponent, which is 3. And c, this e is an actual number. It's in your calculator, and I'll show you in class how to get that number in your calculator. So that e is our base. It's like a script e, italicized, I guess. So you could say it's log base e of 9 equals the exponent, which is y. Now, log base e is a special log, and we call it natural log. And so what log base e equals, and what we use as for its notation, is ln. So if log base E equals ln, the actual answer for C is the natural log, and it stands for natural log, of 9 equals y. Okay, remember, ln stands for, and I'll write it right here, natural log. That's what the ln stands for, and it's always log base E is actually natural log. So pause here, try your checkpoints. When you come back, I'll give you your answers. All right, checkpoint 2A is log base 2 of x equals 5. B is log base B of 27 equals 3. And C is the natural log of 33 equals y. Okay, let's do example 3, how to evaluate these logs. And so we have A, log base 2 of 16. We want to get an actual answer for this. Well, the easiest way to do it is change it back to exponential form, because we know kind of how to work with exponential form. And so if we changed it back to exponential form, and we said, all right, I don't know what the power is. I know the base is 2, but I don't know what the power is because we don't have this thing equal to anything. So let's put that question mark up there. You could put an X up there if you wanted to. And we know that 2 to some power equals 16. So what we want to find out is what goes in for the question mark. 2 to what power equals 16? And that's the answer to our log. So if you take 2 to the 4th, you get 16. And you might just, in some of these, you might just have to take a calculator and keep doing 2 to a certain power until you find out which one gives you 16. But I know that 2 to the 4th equals 16. So my answer is 4. So the log base 2 of 16 equals 4. Let's look at B. We've got 3 to some power, and that has to equal 9. Well, we know, most everybody should know, 3 squared equals 9. So the log base 3 of 9 equals 2. And this is the tricky one. Log 25 of 5. Log base 25 of 5. So that would be 25 to what equals 5? Well, the number's getting smaller. And we got to think of something that connects 25, what can we do to that 25 to make it come down to an answer of 5? And if you think about it, it would be the square root. So the square root of 25 equals 5. So we got to take the square root somehow. Well, we got to write the square root as a power. And we did this first semester. To write the square root as a power, we would say that's 25 to the 1/2. That equals 5. And that means our answer for log base 25 of 5 is 1/2. Let's circle that. Circle our answers here. Since they kind of got pushed together. So log base 25 of 5, to write it as the square root of 25, you write it as 1/2, so that means the power is 1/2, which is the answer. Try your checkpoints, and when you come back, pause, and when you come back, I'll give you the answers. All right, checkpoint 3, log base 10 of 100, that equals 2. B, log base 3 of 3, that equals 1. 3 to the 1, 3 to the first equals 3. And C, log base 36 of 6, that again is a square root, so it's 1/2. That's all I have for part 1. We will pick up with part 2 in the next video. I'll see you in class.